So the first scientist we're going to look at is Robert Boyle. And so we talked about the combined gas law, which had pressure, volume, moles, and temperature. So each of these scientists studied just two of these variables, and they only made one change. So Robert Boyle studied the pressure, and he studied the volume. So pressure and volume are the two that he looks at. And so the two variables that stayed constant, I'll come back to that in just a second, would be the other part of the formula, which were moles, or the amount, moles, which is an amount. So he kept the amount of the substance the same, and he kept temperature the same. So temperature and the amount stay the same when Boyle's studied his. So for example, if we had some gases in a certain container and they're moving around and we have a certain pressure in here, say 1 atm, if we make the volume less, so we're going to squeeze these molecules closer together, same number of molecules, then that's going to build up more pressure. And so what he found was that these were inversely related. Inversely related means if one thing goes up, the other thing goes down. So they're opposite one another. So if we lower the volume, the pressure is going to increase. And if we increase the volume, the pressure is going to decrease. So pressure volume are inversely related as long as we're keeping the amount and the temperature the same. And so the formula for Boyle's law is really the top part of the combined gas law. It's P1V1 equals P2V2. So that is Boyle's law. So let's do an example. It says the sample of nitrogen collected in a laboratory occupies a volume, so we know the volume, at a pressure of 0.971 atmospheres. And what volume, question mark, will the gas occupy if we change the pressure? So you see we're only making one change this time, and we're increasing the pressure. You can see the pressure has gone up. So we would expect the volume to go down. So if you're only making one change and you're studying those, so it doesn't mention what says assuming temperature remains the same, so I can just ignore that. And then moles have not changing. Moles don't usually change. So we just have this part of the formula for Boyle's law. It looks a lot like a dilution, except it's pressure instead of molarity. So we've got 0.0971 atmospheres starting at 725 milliliters, and we are looking to change the pressure, so we're increasing that pressure. What's going to happen to the volume? We're going to multiply and divide by the 1.4, and you would find that the new volume, three significant digits, is 503, and the unit is going to be the same as that one. It's going to be in milliliters. Okay, that's Boyle's law.